as promised, I'm going to show you now a video demonstration introducing you to both the Scratch platform as well as showing you how to make this game FlappyBird. So let's start off by what our end result should basically be like. When I press start, the bird, nothing happened. The bird gets to fly up, right? And each time it crosses a pipe, it gains an extra point. If I crash the pipe, the bird falls to the ground and everything else stops. So this is what we're achieving or trying to achieve in our game. So let's go into scratch.mit.edu. Just in case you need to see how to spell that, let me zoom in for you and highlight it. Okay. So the very first thing you want to do is you want to create your own account. So I've already created my account, so I'm not going to do it. After you create a new account, make sure you log into your email and verify your Scratch account, or else you won't be able to share your projects with me and everyone else in the world. So the first thing you want to do is you want to click Create. And let's wait for it to load up. Okay. So once you've got this canvas, okay, let me first introduce you to the different parts of Scratch. All right. So here you have the way to make your sprites. Your sprites are basically objects in your game. It could be characters, it could be things you're shooting, things you're throwing, symbols. There are many different ways to make characters. So the first way you can make a character is by choosing the sprite from the library. So there are many different symbols and things in this library. You can explore it and choose to create a character from here. All right. You could also draw your own character. You could take a picture and create a character. For example, this is great for creating your face. Or you could do what we're gonna do, and what we're gonna do is go ahead and select a character from a library, because I don't really want you guys to waste time creating symbols and characters of your own. I want you to focus on the programming aspect of it. So the sprites that I'm going to use here, there are 3 sprites called Pipe, Ground, and Bird. They're all going to be linked in this video description below. All right. Just select them all and click Open. So there's the ground, there's the pipe, and there's our bird. So for this game, we don't need the cat anymore. So what we can do with the cat is just right-click on it and go down to Delete, get rid of it. All right. We're gonna right-click on our bird and hide the bird, because we don't want to focus on that at the beginning. We want to right-click on the ground and hide the ground. We don't want to focus on that either. All right. Okay. So the way that this interface works is what you want to do is you want to create each objects, and these objects interact with each other and they make something happen, and that's the basic idea of a game. So let me show you how we would go about that. Let's first and foremost focus on the ground. See, every time I select the pipes, every time I select the pipes, it shows me that the object on the canvas that has been selected. So as an introduction to Scratch, Scratch lets you play around with a grid. This canvas that you see here in white, you can think of it as a grid coordinate system. And if you go back to your basic math, understanding your grids, at the very center of this grid, you reach the coordinates 0, 0. If you focus on this x and y, you see that this x somewhere around the center of this grid is about 0, 0, right? I'm not very good at finding the center. At the very center of the grid, the coordinate system would be 0, 0. Okay? So x, the value for x, remember x is going to be along your horizontal plane, will be from 0 to, if you look at where my mouse goes here, it's about 240, and from 0 to about negative 240. All right? Y goes from 0 to 180 and from 0 to negative 180. So your entire grid is about from negative 240 to 240 for x, and your y goes from negative 180 to 180. All right. So y is the vertical and x is your horizontal planes. So that's the first and most important thing to understand. One of the things that we want to focus on is this tab right here, labeled motion, deals entirely with all the concepts of movement and rotation and x and y position. All right. Okay. So that's how we're going to start off with this game. So this button up here, it's a start button. Okay. This green flag is a start button. So when you click on this flag, it will run whatever script you have placed on this side. And if you click on this red button, it will stop running the script that you have placed on this side. Right now, nothing is happening because we have no script, obviously. So the very first thing we want to do is go into events. All right. This tab has a control for all the possible events that your system, that the Scratch system can react to. So the first thing it can react to is, for example, when you click the start flag. All right. It could react to when you click a key. So instead of space, you could click any key you want on the keyboard, and you can have it react to that. It could react to when I click this sprite. I could command it to do something when this sprite is clicked. Okay, so I could have it react to different things. Let's start off by playing around with the pipes. The first thing we want to do is we want to drag out this when flag is clicked. So now when flag is clicked, whatever is attached under this part will now run. Nothing is attached, so nothing runs. If I go into my motion and pull out this go to XY coordinate, just so I can highlight to you where the center is, change my X to 0, change my Y to 0, and then I press run, you'll see that the pipe will center itself to 0, 0. All right. Now, we can't really have this. In our game, we don't want the pipes to start off at the center. Yeah? It'll leave a gap. It leaves this ugly gap at the top and this ugly gap at the bottom. The gap at the bottom we can deal with by putting in a ground. But what about the ugly gap at the top? So what I can do is, okay, the first thing I can do is I could fill the bottom and the top by putting in 2 grounds. If you'd like, that's one way to do it. What I'm going to do is I'm going to shift the whole thing slightly to the top, about here, right? So you'd think that this part moving, right, to the top, this would be your Y value would be -180, but it wouldn't, because the sprite's grid system, it starts from its center, and the sprite's center is somewhere about here, right? The sprite center is somewhere around here. So what we need to do is you can play around with these numbers a little bit. Let's say if I moved the sprite up 20 and left the X at 0, let's see what happens. So see, that kind of takes my sprite to the top. If I moved it up, if I moved it down a little bit, let's say something like 15, and I press start, that's a good place to be as well. I'm going to move it down even more, and let's say 10. My Y is 10. And then you see it leaves a little gap there. So 15 is a good number to have it at. So let's leave it at 15. How about our x coordinate? So the way that the FlappyBird game works is every pipe comes in from the left-hand side of from the right-hand side of the screen, and the pipes travel from the right-hand side all the way to the left-hand side. Right? So that's what we want to recreate. If that's what we want to recreate, then our starting position for this sprite shouldn't be at 0. It should be at x equals wherever here is. And remember, the max you can go on x is -240, or 240 to be exact. So if I press that and I clicked OK, you see it starts from there. What I can do to make it look like my pipe is coming from off the screen, I can actually make it equal a little bit larger than 240. I can make it 250. If I press start, you see what happens. All right. So now it looks like it's coming out of the screen. Now what I want to do is I want to give this, I want to give my pipe some motion. All right. So what I could do is, for example, is I could change my x coordinate from the motion tab. I can pull out this change x by, right? Pull it right under here, and I can say, all right, why don't you change by, let's say, 4 steps. and I press start, and as you can see, it changed by 4 steps, but nothing really happened. To make this more prominent, what if I said change by 20 steps? All right, so you can see what's happening. Nothing. Okay, and nothing is happening because we are moved to the maximum position of this grid. If you want to move in this direction, in the left direction, then you would move by, you wouldn't change x by 10, because changing x by positive 10 would move to the right, right? It would make your object move to the right, and you cannot move to the right here. So we're going to move by negative 10, so you'd move to the left. So if I change this number to negative 10 and press start, you can see that it moved a little bit, but it only moved once. It only moved once, and then it stopped moving. What I want is I want this to move continuously. I want it to move from one side of the screen all the way to the other side of the screen. I want it to move on a continuous basis. I don't want it to just move one time and stop. And what we need to do for that is we need to look at this control tab, and we need to look at this repeat until or this forever loop. Okay? Let's take a break. In fact, let's not. Let's continue. So what would happen is if I took the forever loop and I put the forever and I put it inside there and I make it continuously. So this loop, what this means is I'm changing x by negative 10 forever, and then I press start. What you can see happening is now it's moving all the way to the other side of the screen. Right? You can see there's a slight lag in this, but the lag is only because the computer I'm using is quite slow. All right, so it's moving all the way to the other side of the screen. All right, what this is known as, both these types of loop, this repeat until and this forever loop, these are known as recursions. Let's go back to the slide that we covered in class, and let's look at what recursion is. So a recursion is a continuous action, a repetition of a sequence until a specific state is reached. Yes, a loop or a while. States can also be achieved in 2 ways. They can be human initiated, or they can be some expected event. Okay, so poorly programmed recursions are loops which don't reach the end of a state. So what a recursion is it will continue to do something. It will continue to do something until you reach a specific state. And let me explain what that means in this context. So when I start, right, when the program starts, this program starts with the sprites right almost at the end of the screen, right? So what I'm saying here is I'm saying change x by negative 10. So it's going to change x by negative 10, and then it's going to change x by negative 10 again, and then it's going to change x by negative 10 again, and it's going to change x by negative 10 again. And this recursion, all it's saying is that it'll change by negative 10 again and again and again and again and again until a specific state is reached. Now the issue with using this forever loop is that it's never reaching any specific state. It's going to continue repeating forever until you're out of boundaries and it can't go no more. That's what's happening here. Okay? So if you come back to the slide for just 1 second, it says poorly programmed recursions are loops which don't reach the end state. Okay? And that's why I've pulled this repeat until out. What I want to emphasize in this classroom is I don't want you to use the forever loops. I always want you to use the repeat until loops. Okay? So as you start off, what you can do is you use the repeat until loops, right? And the repeat until loops are going to get you, if you leave no condition inside this repeat until loop, if you say repeat until and you leave this portion right here blank, it will just work like a forever loop. Yeah? But as you continue creating your game, you can think about, okay, when should this loop stop? And then you can put that condition in there. All right, so that's what we want to do. Let's make our pipes move a little slower. Okay, let's make it move, let's say -4 steps at a time. And if I press start, all right, now you see that it's moving across a little bit slower. All right, so it's moving -4. X is changing x by -4, and then it's doing it again, and it's changing x by -4, and it's doing it again, and it's changing x by -4, and it's doing it again, okay? And it just continues to happen again and again and again and again on a continuous basis. So, all right, now let's look at the costume inside my pipe. Let's look at the costumes. As you can see, I've created 1, 2, 3, 4, 5 different costumes for you. And each costume represents a different height between the pipes. Okay? So that being said, what you can do is you can create, instead of creating a new pipe altogether or a new sprite, each individual sprite that the bird encounters could just be incorporated, could just come out as a different costume rather than a brand new pipe itself. So let's go back here and let me introduce you to some new concepts. All right. So what I want to do is I want to create multiple copies of the same pipe. I want to create multiple copies of the same pipe. So the way that I can do that is when the game starts, I can go to a certain position. Maybe I don't have to go to a certain position. Instead of going into a certain position, I can just go into Control, and I can pull out this one, which says Create Clone of Myself. I pull it out, and I put it up here. Okay? So what I'm doing when the game starts is I'm creating a clone of myself. If you want to be more specific, what you can do is inside this myself, you can say pipe, because you're creating a clone of a pipe instead of a clone of yourself. Right? What you do next is you pull out this when I start as clone, and you say, okay, so when the game starts, I'm going to create a clone of myself, and then when I start as a clone, I want to go to this position where x is equal to negative 250 and y is equal to 10, and I'm going to repeat until I haven't set a condition yet and go all the way to the other side. So right now it should do the same thing. If you press the flag, see, it's doing the same thing, right? It's doing the same thing as what we had before. But it's creating a copy of itself, and it's not creating itself again and again and again. And when I click stop, you see this thing, this original pipe, it still remains. It didn't disappear. So I've created a clone, and I'm working with the clone or the copy of itself, but I'm not getting rid of the original pipe. So what I can do as a workaround is I can go into this looks tab, and I can pull out a hide. So when the game starts, I'm going to hide the original pipe, and I'm going to create a copy of itself. But as you can see, when I press start, nothing happens. Because essentially what I've done is I've hidden the pipe, and I need to find a way to show it before I can continue. So what I can do is every time when the clone is created, I pull out the show tab, drop it at the bottom there, and now when I press start, well, now you have a pipe that comes through every time. Okay? So I'm just going to right click on my canvas and press clean up, just so everything looks a little bit neater, right? Oh, okay, so what we want to do is every time a new pipe comes out, a new clone is created, a new copy of my pipe is created, I want it to come out with a different costume. The costume should come out at random. It shouldn't come out at the same time. And costumes are controlled within this looks tab. So if I say switch costume to, all right, I can pull out the switch costume to, and I can pull it out there and put it there. And if I press start, okay, you'll see that it just came with a different costume. If I press start again, it'll always come out with costume 2. So that hasn't really helped me in any way. I've just switched it from one costume all the time to a different costume all the time. So luckily, inside the operators where we deal with numbers, equaling, making, checking whether numbers are equal, adding, subtracting, dividing, multiplying, we have a function that says pick random. And what we can do is we can take this pick random out and put it into this switch costume. And if you go back into the costume tabs as a recap, remember this, I've labeled this as this is your first costume, this is your second costume, third, fourth, and fifth. And you can see the numbers correlate up here on the top left-hand corner of each costume. So what I can do is I can go back to script, and inside this pick random, I can say, okay, what I want to do is every time I start as a copy or as a clone of myself, I'm going to pick between the numbers 1 and between the numbers 5, because those are the costumes that I have. Now, every time I click start, what you will see is a different costume should come out. because it's picking a different costume at random. Okay? But I'm clicking start all the time. See, if I don't keep clicking start, it just goes to the end of the screen and it gets stuck. Right? It comes to the end of the screen and then it gets stuck and nothing happens. So what I want to do is I want to continuously, on a continuous basis, I want to have a new pipe come out. Right? I want to have a new pipe come out on a continuous basis. And the way that I could do that, and the way that I would do that is actually quite simple. What I would do is I would well, there's many ways you can do it, right? There's multiple ways to do it. So let me show you one of the ways you can do it. One of the ways that you could do it is using conditionals. So you can say, all right, when my pipe reaches a certain number, okay, it's moving along the x-axis, right? It's moving along the x-axis. Let me demonstrate that again by clicking that flag. It's moving along that x-axis. So when my pipe reaches, let's say x equals 97, somewhere around here, I want to create another clone of myself. Okay, every time the x value of my pipe is equal to about 97. Let's say 100. All right, let's say 100. Let's say when my x value is 100, yeah, somewhere exactly here, right? Exactly here. Then I want to create a new clone. I want to copy myself again, and my copy will start from, it'll start with a random costume. It will start from this x position and this y position, right? I'm sorry, I'm just going to move these things around a little bit, right? It's going to start from this x position. In fact, what you should do is you should choose the costume first, and then go to the XY position, and then show. All right. This is a little bit of sequencing. It's not very important. You could have it the other way around, but you know, this way works well. So what I can do is I can go into my controls again, and I can pull out this if-then loop. All right. Now, before I cover this if-then loop, I want to go back to the slide that we had last that we covered in class and look at something called conditionals. So the conditionals are something that takes an action in response to a specific condition. All right. So all computer systems react to these conditions. All right. So there's also two types. There's human-initiated condition. This is, for instance, when you press a button and there's an expected event. So for example, in this case, when our pipe is traveling along the x-axis and x is equal to 100, that's an expected event. Okay? And this if-then lets us create a condition for it. All right? So if-then, all right? If-then. This is what we're going to use. Sorry, excuse me. So inside my if-then, I'm going to go into my operators, right? And I'm going to pull out this block here that says something is equal to something. All right? I'm going to pull out this block. Okay, it says something is equal to something. And what I'm going to do inside that block is I'm going to go back into my motion and find the x position of my sprite, of this sprite. Right? I'm going to pull out this x position and I'm going to put it in there. And I'm going to say, okay, so if my x position is equal to 100, okay, if my x position is equal to 100, then what I want to do is I want to create a clone of myself, right? So I'm going to go up here and it says create clone of pipe, right? Click on this, duplicate it so I can use it again and drop it inside this if statement. I'm going to bring this if statement and I'm going to drop it here, all right? Now, what you'll see is nothing will happen, and nothing happened for a very specific reason, all right? And the reason is, well, I clicked the start button. So it hid the original piece, it created a clone, and once it created a clone, it started running this part of the code. It selected a random costume, it went to this XY coordinate, it showed itself, and then it moved from this coordinate, where x is equal to 250, and it minus 4 all the way until it got to the other side, right? So the thing is, while it did that, after this finished, it checked this. Right? After this if part can only be checked once this loop is complete. Okay? And when this loop is complete, the x position is not equal to 100. All right? Somewhere inside this loop, while this loop is occurring, yeah, so while this loop is occurring, it should check whether the X position is 100. So what we need to do for this to work is, if this check needs to require while this loop is running and not after this loop is finished, then we need to put this if inside this repeat loop. Okay? So the issue is that everything in a computer program is sequential. If you put it out here, it'll do this, it'll do this, it'll do this, it'll do this, this, then it will do this. And until this loop is finished, it will never execute this. Right? This will never get executed. Okay? And since this repeat condition doesn't have an end sequence, it just never gets executed. This part would just never ever get executed, and that's an issue. So we want this part to get, we want our Scratch platform to run this part of the code. So we're going to put this part inside here. And every time, now what's going to happen is every time this pipe, let me take this pipe out. Every time this pipe moves, changes X by -4, it's going to check, is the X position equal to -100? Because if it is, then I need to create another clone of myself. Let's try it out now. Okay? And as you can see, nothing still happens. Because, and this is kind of complicated to understand, but let's zoom in on this part of the code and take a look at it in a little bit more detail. So the X position of our pipe starts off at 250, and it's going down by -4. It's changing X by -4 at every time. What that means is the first coordinate is at 250. The next X coordinate, or the X position of our pipe, okay, if it's going to go down by -4 each time, is 246. And the next position is 242. And then the next position is 238. So on and so forth. So given that it's always going down by -4, it's never going to reach this number 100, right? It's never going to reach this number 100. It doesn't mean that it just needs to be a common factor of the two. That's not enough, because if you keep going from 250, if you keep going down by -4, you'll see that you never come across the number 100, right? Because 250, right, is not a factor of 4. So the best way to do this is find numbers that are all factors of each other. All right. So what I can do, right? What I can do is, for simplicity's sake, if I change this number, let's say to -2, and it's just an easy number to work with, and then I press start, every time it reached around here, it should create a new pipe, and there you see it. It does it. It's fantastic. All right. So my system is slowing down a little bit right now because there's a lot of things running, and that's why you see a little bit of a lag. But on your system, you shouldn't have this lag. This is generally, it should work quite well. Okay. So I'm going to stop my code now. All right. Okay. So this is the first segment of the pipe, and I feel like it's complete. So let's come back and figure out how to solve the other problems in the next video. Thank you.